How's it going, guys? Okay, so this is lesson 5. How do scientists engage in arguments? So, first off, let's discuss what I mean by arguments. I don't mean arguments that involve yelling, finger pointing, name calling. These are arguments that uh, have complete explanations and compare explanations and results, and they evaluate evidence and maybe cite that evidence and come up with scientific reasoning. These are arguments that dig deeper and they're aimed towards answering a question or developing a solution. These people are working towards the same goal. So in the science community, we're not working against each other, we're working with each other. So just because there might be competing companies at the root of all of it in science, the idea is that we're trying to work together to answer a question, or we're trying to work together to develop solutions to human need problems. So I'm going to focus on this again. Remember the difference between science and engineering. So in science, we are answering questions about phenomena, and in engineering, we are developing a design that meets a human need. So in science, the reason why we have arguments is because we're trying to get the best explanation, not just a explanation, but the best explanation. So that's what we argue for in science. Now, in engineering, we're arguing to get the best solution. So not just a solution, but the best solution. So that's the point of arguing in science and in engineering. The debates go on because we're um, at means to hit a goal. Let me tell you a little bit like what this looks like. So arguments in science. Okay, John Dalton, 1808, had this idea, this argument that um, perhaps all matter, every piece of matter out there, is made of little tiny little bits, fundamental bits, indivisible bits. I bolded that word for a reason. Indivisible meaning you can't divide it anymore. You can't chop up in something that's indivisible. It is the smallest it can possibly be. And he called this atomic bits, atoms. So that was John Dalton's theory in 1808. Now, here's where the argument comes in. Some people accepted the atomic theory, but J.J. Thomson challenged the atomic theory. And what he said is that can't be true because there comes in this evidence of reasoning. Atoms can break down into two parts when they're excited by an electrical current electricity. So there must be some form of negative base and positive base. And he said that the negative parts were embedded in the positive parts. He compared this to like a pudding pie. Like he had like a plum pudding and the little pieces of plum in a plum pudding pie. That's where he coined some of his terms. But so that was J.J. Thomson's argument. So he progressed the conversation. But then Ernest Rutherford came in, argued a little further, and he said that there must be a tiny, dense, positive nucleus that caused deflections when he shot a beam of alpha particles at a gold foil. So he like had a sheet of gold foil, and whenever he shot the alpha particles through, it actually um, was concentrated in certain areas. There's like a positive nucleus, and there was a negative um, electron ring outside of that. So that's where he got the model that we kind of have today, where in an atom there's a positive nucleus. It's made up of protons, neutrons, and then there's the electron rings around said nucleus. So that's an argument right there in science that progressed what we know as you know as the atom. Now we have a better understanding. There's a better explanation. Let's look at this in engineering. We're gonna watch a little video about this later on this year. This is a really cool story. I don't think a lot of people know this. So in in the electrical engineering world, there existed these kind of two big figures: Nikola Tesla, and Thomas Edison, both genius inventors. Thomas Edison had already developed direct current technology, meaning that like what you have in like a battery takes electrons and it puts it into one string where they travel, and they will travel until they run out. Right, it's the supply, and that's direct current electricity. And then there's an alternating current, AC, where it goes back and forth essentially. Now, Thomas Edison, developed direct current, and he was trying to build basically a city or a world that relied on direct current electricity. And he believed it was the only option. But the problem is that he was going to have to build a DC power plant every 1 square mile because the current can only travel so far. Okay, it can only travel 1 mile. But there existed another form of current electricity out there, current generation, and that was alternating current. And this is where Nikola Tesla came in. Nikola Tesla actually believed in this so much, he developed technology that he believed would be the future. He actually went to work for Edison, argued his point, saying, "Hey, like AC, this is what I think is going to be the future." He wanted to work with Edison. He didn't want to work under Edison's wing per se, but he did want to work with Edison. And Edison just shut him down. He wasn't open to hearing the argument. He felt, no way, AC is too dangerous because the voltage is too high. There is no way we're going to do AC. We need to focus on this, DC. We need to come up with a more optimum system for DC, direct current. And Nikola Tesla went out on his own. He formed alternating current power plants that could power hundreds of miles. He ended up creating a transformer. Transformer technology already existed, but he adapted the transformer to his power plant, which would step down the voltage before actually reaching panels. So Nikola Tesla basically won the argument. But this was a progression in the engineering world. So how do we engage in arguments? There's a clear-cut way to engage in arguments. It's not a shouting back and forth match. It's all about what kind of claim are you making, how sufficient is your evidence, and how can you reason that evidence to your claim. That's it. And how I like to describe this to my students is with something they're probably familiar with in the lower elementary grades. And that's the green, yellow, red writing. If you guys ever remember this, you had the green, which was your topic sentence, your yellow was your supporting details, and then your red was your closing sentence. And this just makes sense to me. I don't know if it makes sense to you, but it makes sense to me. So your claim is going to be your main idea, your statement. This is your argument. I think blah, 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 blah. Actually, no, you don't want to say I think. That's not a claim. That's an opinion. This. That's my claim. Okay? The sky is blue. My claim. Evidence. Okay? Evidence. Well, that is where we get into data or some type of cited information. Evidence needs to be, some data you collected that you will then take that, supporting details, and reason back to your claim. Reasoning, scientific reasoning, is ideas and principles that make logical connections and shows how your evidence supports your claim. We're going to get into this further, so you don't need to understand this, but there's the 3 parts: claim, evidence, reasoning, CER. We're going to learn about that in the next video. But that's it for today, and more on this next time.